So, greetings from Ankara, Turkey. Thank you for having me, being part of this event, and letting me present a bit of my research. So, I will talk about simplicial structure and higher correspondences. Um, so, what I will do is go briefly through a classical story, which is categories, functors, and profunctors, and present how functors are classified by diagrams of profunctors from a double categorical perspective. Um, then I will present a version of this story for simplicial sets, which is of interest. So one of the reasons for studying this, or for me studying this, is to give a precise statement of Luhr's idea of how to classify inner fibrations. Uh, okay, so uh, we all know or have heard of what is a profunctor. There are many ways to define what a profunctor is. So the most common way for two categories C and D is to define profunctor as a functor C across D2 sets. So this is the notion of bimodule for categories. So another interesting way to look at profunctors is as collages. So these are categories formed from C and D by joining uh, objects of C and objects of D with new arrows like I've shown in this picture here, such that we form a category. A more elegant way to put this is saying that we construct a category U with a map to the categorical interval delta 1 with fibers C and D. Well, this third perspective is interesting because it allows us to talk, for example, about uh, pro-arrows or correspondences between simplicial sets, for example. All right, so profunctors and functors organize themselves into a double category. So we call that a double category consists of objects, two types of morphisms, horizontal and vertical, and two cells, which look like squares, um, satisfying usual two categorical rules, interchange law, and things like that. So our main example is, of course, categories, functors, and profunctors, which form a double category. Um, right. So one of the reasons for liking this double categorical structure is that we have a degree of freedom which allows us to define interesting things. So one of those interesting things is double colimits, which were introduced by Grandis and Pare. So if I have a diagram into the horizontal part of a double category, uh, diagram F like this, I can define something called double colimit, which is basically a universal vertical cone. So this means that for each object in the diagram, I have a map to the double colimit, and for each morphism in the diagram, I have a cell. So this triangle here is a two-cell universal with respect to the double categorical structure. So I have horizontal diagram and a vertical double colimit. So this is how all these are tied together. If I have any functor into a category A, F, from a category X, this gives me a diagram of profunctors just by looking at the fibers. So for each object A, the fiber is a category. And for each morphism F in the category A, its fiber is a profunctor. So I get this diagram. And actually, this completely determines the functor F. So we have this equivalence of categories from the slice over A into the category of diagrams of profunctors indexed by A, which are lex. And this equivalence is realized by inserting this double colimit functor, which allows us for each diagram to produce a category over A. Yes, so this is a very interesting statement. People, I think, know this, but I haven't seen this presented in this double categorical form before, so I thought I'd share this with you. All right, so this is a part of a more general pattern. For example, we have such correspondence theorems in the category of sets. Functions over set A are determined by its fibers, by taking, so by A families of sets, right? And we just saw such a statement for categories. And Lurie points out that inner fibrations over simplicial set A um, should be classified by A diagrams of correspondences of infinity categories. So this statement is similar to these. And in general, I mean, we would ask, what is a simplicial map classified by A diagrams of what? So I will propose uh, something here for this question mark. So of course, we have to look at correspondences between simplicial sets. So these are just maps to delta 1, straight generalizing from categories. But we don't have the double category here because we cannot compose these correspondences. And to redeem this, we have this simplicial structure if we take into account higher correspondences. So maps from a simplicial set to delta n, let's call them n correspondences. And we can form this simplicial object in categories. So when I say simplicial category, this is what I mean. Whose category of n simplices is exactly the category of n correspondences, right? So having such a simplicial object uh, allows us to do some double category theory because each simplicial object in categories, say E, um, can be thought of as a double categorical structure with objects, those of E0, vertical arrows, those of E0, like the ones I've depicted here. And on the horizontal part, we will have a simplicial structure and um, morphisms in En for various n will be these cells prism shaped like this. For example, this is like a 2-cell in a double category. It's a morphism in E1. So these are double twofold analogs, let's say, of simplically enriched categories. And they will allow us, for example, to develop concepts such as colimits, double colimits. And we can prove some results with this structure. So this is the part, one of the things this formalizes. If I have any simplicial map and I look at the fibers of n simplices of A, they will be n correspondences by definition. So then I have this map from A to S set sharp, which was my simplicial category. So this respects the simplicial structure. And so we have this equivalence of categories, or even simplicially enriched categories, if we insist, given by taking double colimits in this simplicial category. Okay, so simplicial maps are classified by diagrams of correspondences of simplicial sets. So this is how we should interpret this statement. And then we get the classifying result for inner fibrations as a corollary of this general theorem. So this is really easy to prove after we know this fact. So in my opinion, this raises some interesting points. So for example, we can ask what is the equipment property for simplicial categories. So we can ask double categorical questions. Uh, or what would it mean for a simplicially enriched category to be equipped with pro-arrows? Or go homotopical here and from the beginning, maybe invoking some notion of infinity double category, or even explore a relationship with model category theory. For example, generalizing the Hammock localization or something of that sort. So, so feel free to contact me if you're interested in any of what I talked, and thanks for listening.